Abhishek joins us today to discuss a little more about strengthening software supply chain security. And today, in particular, we'll be focusing on a tool named Bolt, which is open source. And I think Abhishek is probably the better person to um, deal with all of that in detail. But before that, just a few quick housekeeping notes. So, this stream and the series of streams are brought to you by the OpenSSF. For those who don't know, the OpenSSF is a Linux Foundation project, and you can check out all of the different OpenSSF projects on openssf.org/projects. It's a vendor neutral home for a lot of security related projects, especially projects that are heavily focused on security within the Linux Foundation. So, apart from that, the OpenSSF is committed to education in the security realm. So, please do check out the free courses that they have on this using this QR. There's also a source fusion event that's coming up. So secure open source software has a flagship event in source fusion. It's going to be held in Atlanta in the month of October. Again, please scan the QR code for information about the event. Without further ado, I present Abhishek. Abhishek, welcome again to the show.
Yeah, thanks, Ram. Thanks for having me again. And it was a pleasure last time talking about software supply chain security from securing the components or hijacking of components point of view. Yeah, and today I would love to talk about Bolt, which is more from securing the configuration and making the whole build environment secure by design.
Awesome. So, can you quickly introduce yourself, maybe for some of the folks that missed it last time?
Sure. So, hi everyone. I'm Abhishek Anand. I am CTO at KoalaLab, co-founder and CTO, and we are building software supply chain security, starting with securing GitHub Actions, and yeah, uh, we want to make the whole software supply chain secure.
So, I'm going to bother you once again with
Okay.
some of the definitions that we saw last time.
Okay.
Can we begin with a very brief definition of supply chain security, please?
Right. So, when we talk about supply chain security, so first we need to understand a supply chain in context of a software. So, when we are developing any kind of software, we bring in uh, the components either from our proprietary components or from open source. We bring the components, then we apply our process to it, like build commands and things, and we develop or generate artifacts, which we then submit it to our artifactory, to our repositories. So this whole thing is called software supply chain, and securing every bit of it is software supply chain security. So basically, this is a new green field for attackers because most of the software, like cloud-based attack vectors, are now being taken care of. And this is a bit overlooked aspect in terms of security. So attackers are aggressively pursuing threat vectors in software supply chain to gain access to your proprietary data or code.
Honestly, that does sound a bit scary. So let's also switch to this other definition that you gave us last time. So secure by design, and how does that play into a lot of these supply chain security aspects?
Right. So, secure by design is it's more of a paradigm that you like. That is like you build your platform in a way that things don't things cannot go wrong. Things will fail before they can go wrong. For example, let's say your environment has excessive permissions, So first, so instead of going ahead with excessive permission, the workflow should fail there. On a broader, for a broader definition, it's like you, example, least the principle of least privileges, that is also a paradigm part of secure by design itself. Like if you are giving the least privileges that are required, then you are secure by design, because those privileges can only be are only available. There is no possibility of a lateral movement over there. Similarly, using not using tokens or long-term tokens is a secure by design. Is secure by design because no one can get access to your tokens. Yeah.
Got it. And are these aspects going to be demonstrated in today's talk about Bolt? And how
Yes,
is that going to play?
certainly, certainly. So, in today's talk, we will talk about the threat vectors that Bolt help you with, and how Bolt Secure by Design takes care of it without without you needing to know much about the threat vectors themselves, or without you having to configure a lot.
All right. Yeah, I can't wait to see the tool in action. For those curious, here's a QR that I've linked to the GitHub repo for Bolt. Do check it out. KoalaLab is a startup that is determined to push the boundary of securing uh, software supply chains in today's very vast and very fast moving ecosystem, especially if it involves a lot of open source software. Bolt, I believe, is fully open source. You can get access to the tool through GitHub, and obviously, please wait for Abhishek to show the demo before you try it. But for those who are really curious, go for it. So, Abhishek, the floor is yours. Take us through.
Yeah, sure. So, I would first share my screen. Yeah, is my screen visible, Ram?
It is.
Yeah. So yeah, everyone. So this is the Bolt's GitHub repository that Ram has shared a QR for. The promise of Bolt is to secure your GitHub Actions with just one line of code. I'll dive into that a bit later. But first, let's understand like what is the need of Bolt. Why we need to secure our CI/CD environment. So, coming back to our earlier definition, where we had software, like where we talked about securing our software supply chain. Uh, so, in that, there are two pieces to that. One is components, where you bring your either your own proprietary code or you bring in open source dependencies. Then comes the process part, where you commit your code in your source code management in your repositories. Then it goes through a build pipeline. Then it goes into your artifactory or your repository, and then it is used from there. The final step, that is deployment. So this is that you can see code flowing through. So what this basically gives you is an overview of software supply chain. Moving on, next is like why like Bolt started with GitHub Actions. As I said, it is to secure with GitHub Actions, secure GitHub Actions with just one line of code. So moving on with, we will see like GitHub Actions. So GitHub Action is like more and more becoming the choice of CI platform for many companies, many organizations. We even went through a report where like there's a blog by JetBrains which did a survey like which CI system companies are using. So GitHub Actions was over there at the second spot in this list. You can see Jenkins on the top, but if you really look at the trends, Jenkins used to be the dominant CI system a decade back, but it is slowly losing popularity in terms of more developer friendly and more shift left friendly CI systems where developers can express their pipelines uh, pipelines directly instead of relying on a separate team to build work on the pipelines. So yeah, then next aspect of GitHub's CIE popularity, like why it is gaining popularity, is this marketplace. So marketplace gives you actions which are like mini workflows, like which you need to do like uh, in your regular CI pipeline jobs, but these are the repeatable or composable pieces that you can use to describe your own pipelines easily. So as you can see, there are almost 23,000 actions available to you, like at your disposal to use them and quickly build a pipeline like in minutes. Like for example, there are actions like go releaser that can let you like build a go language, like a uh, golang project in minutes, like literally minutes, because like it will take care of all packaging and building docker images, uploading everything. So yeah. So then with all this, like what happened is your CI environment moved to a uh, third party platform or vendor, and moreover, due to this introduction of marketplace, the another thing that happened is third party code got access, like in a way got access, or third party code is now being executed in your build environment. So what this does is it exposes you to certain threat vectors, like where you need to take care of, which was not there earlier, because most of the things you are writing yourselves. Still, there were issues, but now the attack surface has, I will say, increased. So before diving into the threat vectors, I will quickly go through few of the popular supply chain attacks that have happened. So you can see here like the two popular ones, the solar winds and the code cow. So in the solar winds example, like their Orion product that was there, it was compromised by attackers using like by taking control of their build system itself. They tampered a file and deployed and that tampered build was deployed to, as you can see, roughly 18,000 customers. So one company got getting compromised, like one company compromising their build system led to 18,000 other organizations having a backdoor in their production environment. This was massive in scale. Similarly, in CodeCove, their bash uploader script was there, which used to upload the CodeCove reports back to CodeCove servers. So that was compromised, and what it was doing, it was sending out your a whole environment to a random URL. So what essentially it could do is, like, if you have any sensitive information in your environment, let's say your AWS access key or ID or some other sensitive token, so that was being exfiltrated to another server, right? So these are the two most popular attacks. There is another, the recent one, libxg was also there, which was like, yeah, which was again putting a backdoor, and it was affecting all the Linux distros itself. So basically, the I will say the key piece of all the software supply chain, that is the distro itself, was compromised in that. So I will now summarize the threat vectors. So the threat vectors that we have now are: number one is exfiltration of secrets, like whatever is happening in your build environment, that can like any sensitive information is there, that can be sent out by a malicious actor uh, to their own domain. So that guides us to use egress filtering or monitoring. For example, whatever network egress is happening from your from your build environment, that needs to be monitored. So that's, I will say, an action to the threat vector, that is secrets exfiltration or data exfiltration. The other one is file tampering. Like, let's say you are building a Docker image. Uh, my malicious script can overwrite that Docker image itself, add a backdoor layer in it, and then create with the same tag. And when you push that tag, a compromised image will be sent to your artifactory. So now, if you deploy that image, your production environment is compromised, right? So that is the threat vector number two. The third one is like more of a excessive permission thing. That is more like having like the principles of least privileges. If you run your build environment with more permissions than it needs, then you are essentially exposing yourself to unknown threat vectors or unknown risks that can be exploited. For example, if you don't want a root permission, you should not have root permission. Like, for example, GitHub runners environment by default, they ship with a passwordless sudo. Like, if you like if you talk to anyone who builds their own CI environment, they will say this is unacceptable. Why would I have a passwordless sudo for my build environment? But GitHub does so that the setup steps could also be part of the pipeline. Like, if some setup step requires sudo, that can be done. But post that, it's not needed, and one should disable it. For example, Bolt uses sudo to configure auditing rules. But once that is done, the sudo should be disabled. And Bolt gives you an option. So those are the threat vectors, I'll say. Having said that, let's dive into what Bolt does for you. So Bolt has two components to it. One is a transparent egress gateway. So what I mean by that is, it will, like, in a transparent manner, take over your egress traffic, right? So all the egress traffic it will monitor, and based on the rules that you have defined, right, it will either allow that traffic to go through, or it will restrict that traffic. So if you have a whitelist of all the domains that you want to send your traffic to, you can configure that in Bolt. I'll quickly jump to the config section so that you can have a look at it. So for example, this is an egress rule in Bolt that I have defined that allow all the subdomains of GitHub. So this is so it will allow that. So yeah. So now let's dive a bit deeper into how Bolt does that. So to do it, what Bolt does is, like, it sets up a transparent proxy in between, and whenever there is and it uses traffic redirection to redirect all the traffic on your machine to that particular proxy. And whenever there is a request, we look for the SSL handshake that is happening. And if the SSL handshake itself, if we find that this domain is not allowed in your egress traffic, we will fail the SSL handshake itself. So it cannot go further. So it works on fully qualified domain names, so that you can describe your policies in terms of domain names instead of IP addresses or subnets. So again, why that is required is a very interesting piece. So if you look at IP addresses, most of the internet is behind some kind of like a CDN itself, which hosts all the internet traffic or all the internet websites. So the first connection that your build system, let's say, will be with an IP address that is that of a known CDN, and some malicious actor can be behind that. So if you are acting just based on the like the domain names, just based on the IP addresses, that won't work out that well for you, because it might be happen that let's say Cloudflare is hosting a website. I whitelist that IP address, but now when some other malicious actor is also behind that only, behind the Cloudflare's proxy itself, so that can be accessed. So that's why we have given destinations in terms of domain names, and it will like look at the exact domain name. If it is allowed, it is allowed. We also support wildcards, so that you don't need to explicitly mention all the subdomains or all the domain patterns that are there. So it's pretty simple. Like you can see egress rules. So I will quickly open a sample run that will tell you that will show you what Bolt actually does. So Ram, any questions still far, or are you able to follow me?
No, I'm able to follow along quite well, to be honest. So the threat vectors make a lot of sense. If there's one thing, maybe make the font a little bigger on the browser.
Sure, sure.
But that's it. That's perfect.
Yeah.
But yeah, otherwise, so far so good. The reason I didn't interrupt was the flow was going very well, and so just keep at it. If there's other questions that I get, I'll post them as appropriate.
Sure, sure. Thank you, Ram. So continuing from here, we can see that Bolt, this is a sample workflow that I have put in a test repository. So here you can see how Bolt is in action. So there is a build job, that's a dummy build job that is running over here, and we have uses Bolt. So this is the only piece that you need to use when you are using Bolt. Other are the configuration app options that you need to customize it. So as you can see, it is Bolt is used here for instrumenting as the first GitHub action step. The other, like the standard ones, like you want to set up Node or you want to set up Java, you want to check out the repository. Then I have made some curl request to emulate a egress traffic, so to show that whether this is allowed or not. So now what happens is once this run is done, you will see that Bolt will generate a summary for you, right? So let's go through the summary. The first piece will be, it will give you all the configuration options with which the Bolt was run. Then we will come to this part in a bit. Let's look at the egress traffic part. Yeah. So we can see that in the egress traffic part, there are calls to API adopt OpenJDK, then there are calls to Ubuntu or Launchpad content. So these calls, as you can see, there is a action associated with them that they will be blocked in active mode. So now this brings us back to another configuration option in Bolt that gives like how you want to run your egress monitoring, or the proxy, the transparent proxy we talked about, in what mode you want to run it to. It can run either in active mode or in audit mode. So if you don't know what to whitelist and what not to whitelist, Bolt will let you run in audit mode so that you can get a list of all the destinations that your workflow is like reaching out to. And based on that, it will create a log for you. Like as we can see here, we ran in audit mode. And if it would have been running in active mode, it would have blocked all these calls. And depending on the like how the action itself is implemented, those actions would have failed. So you remember like connecting it back to the earlier like secure by design principles. Like if I am going against security, I will fail fast, right? So if let's say I am not allowed to call this particular domain in my build environment, it's like my build itself will fail at that point of time because this call will be blocked. So continuing ahead from that, there are certain known destinations as well, like which are required by GitHub Actions or which are allowed by, for example, your config the egress rules that you have. So those are like collapsed for your convenience, so that you don't need to go through the same stuff again and again. And these like the unknown ones, which are not explicitly defined, which are not essential to be run a GitHub uh, workflow or GitHub action, those are displayed here. Now, coming back to the Bolt's configuration options, we will like let's talk about the egress traffic a bit at a bit deeper level. What I mean by that is that now we are aware that which all domains our traffic is going, right? So let's assume that okay, now I trust GitHub. I'll say allow all the traffic to GitHub, right? But a malicious player can host their own page on GitHub or their own repo on GitHub and make an API call and send some data or send my packages to their own like account. So that way, exfiltration is still possible. Even if I trust those domains, I will trust GitHub because it's necessary to like, uh, it's necessary for the overall action in itself to run, right? So, so to do that, what we do is we do DB SSL inspection. We look at the even the HTTPS traffic going out of the system, and we have mapped like we identify which GitHub account, for example, you are communicating to. In our terminology, we say like your GitHub account is gossiping with some other GitHub account or what behind your back or something like that. So we take a look at that, like which GitHub accounts your workflow is talking to or communicating with, and we flag that to you. Like there are trusted GitHub accounts, this setting that you can see. So if you trust a particular GitHub account, you will allow that to to communication to that. If you don't trust a GitHub account, you should block that communication, right? So on the same lines, I will show you how Bolt generates a report for that. So here we can see, first let me show you the workflow file itself. So in this, we were making two GitHub accounts. We are making some API calls, and yeah. So what this does is it generates the all the GitHub accounts that this particular build environment has communicated with. So we can see that the Razorpay account that we communicated with has been highlighted here. There are two others, the teammate and Tamarinate binaries. So basically, this one is not a malicious one, even though we don't trust this one explicitly. This is by a setup Java command that we run. But as you can see, setup Java is communicating with another GitHub account, getting the binaries from there. Tomorrow, let's say some malicious actor is able to gain access to this particular repository. They can change. They can change some things, like they can tamper with the build itself. So in such a scenario, it's always a good idea to only trust GitHub accounts which have a very high reputation. Like otherwise, if your actions, let's say under the hood, are communicating with actions which are like or repositories which are not that well maintained, like the number of there is not much activity. So stale accounts are more prone to like malicious takeovers. So so it's always a good idea to look through or skim through the GitHub accounts your build environment is communicating with, and then only whitelist or only trust the accounts that you really can trust, and even in the long run, you trust them to be working in good faith. So similarly, another action.
Abhishek, I
Yeah,
just wanted to interject with a question here. So
sure.
I wanted to check how much this is applicable to a situation where there's you know more of a more of an internal sort of situation. So we have actions that are building internally for a single organization. So
Right.
how much of in your experience, how much of interaction do you see these kind of accounts doing with a lot of third party and other outside accounts?
Right, right. See, so there are two aspects to it. So let's say the action that you are using is is a trusted action, but that has been compromised. Like for example, the case happened with Code Cove. So Code Cove is used by everyone. Like most of the open source projects do use it, but their upload script was compromised. So it started sending data to a domain that, like for example, it was some .ru domain or something like that, that you cannot trust. Like you don't know, you don't identify that domain, you don't know why some data is being sent to that domain. So that's a immediate red flag. So now, like extending that same analogy, let's say now, uh, like for example, someone is kind of using GitHub uh, as a face. Like for example, that traffic is going to GitHub, but whether that traffic is going to a trusted GitHub account or not, right? So now you will say, okay, my traffic is going to GitHub only. It's all right, but it's also very important to further inspect and figure out whether it is going to your own account only or your trusted account only. So as you rightly like pointed out, like is there a need that like my build script is communicating to a lot of GitHub accounts? So answer is no. Ideally, it should be self-contained, like your GitHub account should be enough. But as more and more we start using actions from the marketplace, and where the real power of GitHub Actions is, like it lets you define, like express your workflows in like in minutes, right? So to do that, you need to use marketplace actions. From there, this risk starts seeping in, where like those actions will be using some other account to bring in binaries, to bring in data. So yeah, from that point of view, it is very important to look at it. And I am just demonstrating GitHub. That's the piece that we have implemented. But we plan to extend it to other known sinks as well, like where other known destinations where people generally send their data. For example, Docker Hub. You are sending your built images to Docker Hub. Not so you need to know that you are sending to your own account only. You're sending, for example, data to your own S3 buckets only. You're sending data to your own ECR repository, or your like whatever container registry you are using.
Got it. So this doesn't necessarily have to be limited to a paradigm like GitHub Actions and things like that. It could be applied to anything, any composable build environment that
Right,
you could.
right. So see, so even if you are using, let's say, uh, like something like not GitHub, like where there is a third-party marketplace, you are still pulling in
Yep.
dependencies, right?
Uh-huh.
So your build environment is already having third-party code, right? So what you need to do is like you need to restrict where all it can communicate to prevent you against the exfiltration threat. So exfiltration is the real threat over here. And that can lead to, for example, if I am able to exfiltrate your AWS secrets, I can do lateral movement to your production account, right? So exfiltration is the real issue that we want to handle. And so the first one was basically, if I categorize it, the simplest is like blocking the IPs. But as we talked, like that is not really the way to go, because domains are important and most of the domains are behind certain set of IPs of CDNs. Then the next level is domains. But even domains, as I say, like that is more like a brand jacking thing, where like behind the GitHub's brand, I am sending data to my own account that I have access to, right? So that kind of like I'm using GitHub's trust, like the trust that people have in GitHub or the trust that people have in Docker Hub. I'm using that to exfiltrate your data, right? So there is another interesting piece like that is
Hmm.
gaining popularity these days. That is around if you go and upload any file, let's say to any open source repositories discussion section or a pull request section. So the link that you get is github.com/that organization, that open source organization's name slash something, and then that file. So now you can upload a tampered file over there and use a
Okay.
GitHub's file and can reference that in a blog that, see, this is a executable that you should download. This is the script that you should run to do this setup. And this is,
Right.
you will see the link that this is github.com/Microsoft, for example, because you have raised a so you are using brand as a proxy for trust, right? And that is not actually, that was, if you remember the last Pinny's session, it was more on the lines of where there were imposter commits. So these are imposter uploads, like intend to be which intend to be uh, from some other source, but they're imposter. They reflect that they are from this particular organization.
Right. The world is seemingly becoming a scarier and scarier place day by day. But that's what that's what all of the security tooling and other things are for. Sorry, I had to break your demo flow earlier. Maybe we can get back to it.
Yeah, yeah. We will. I'll continue from. So yeah. So we got through this part where we talked about the GitHub trusted repos and things like that. Then let's look at the configuration options once again. So the next is passwordless sudo. So in the threat vectors, I talked about the principle of least privileges. So in continuation to that, uh, so we believe that you should be aware of where all the sudo is being used. So if you go tomorrow and disable sudo, it might be that some of your actions starts failing. So as an example, I'll show that, for example, Bolt uses sudo that is required, but Bolt, if you disable sudo, Bolt will complete its sudo task and then disable the sudo for rest. And then you can see that this particular action that we have used, they also use sudo. So now it's a thing to go and inspect further that why uh, this particular action requires sudo. If it's a legitimate use case, if there is a way to bypass that, do it without sudo. Interestingly, this particular action given has an option that lets you configure to use it without sudo. So, so essentially, most of the actions that we have come across, they don't require sudo access. So the best way to go about it is just simply disable the passwordless sudo, set this flag to true, and disable it. So that it fails. And before disabling it, in the default mode, it will just give you the list of all the actions which are using sudo, so that you will be aware that where to expect failures or what you need to replace in your workflow for it to succeed. Right? Yeah. So uh, yeah. Uh, so, um, hmm. so this kind of these are the capabilities of Bolt. Another capability of Bolt is that is not yet open, not part of the open source. We are still developing it. It's like generating the events that the network events and as well as uh, network events as well as file events, like the process related from audit system, and then correlating them to figure out if a particular action is tampering a particular file or not. Like, for example, as I said, your build command, for example, if you are running docker build, if some malicious actor comes and runs again a docker build and overrides that tag, so that's a red flag. You need to know about that. So Bolt does a thorough inspection of all these things. We have not open sourced these capabilities as of now. So yeah, so Bolt will figure out whether you have like anyone is overwriting, let's say, your Docker images. Bolt will figure out whether anyone is overwriting your particular files. For example, in the case of SolarWinds, what had happened was the after attackers gained access to the build system, they put a script there, which during the build process used to replace a particular file with their own backdoor code. So, and that was baked into the final, like the artifacts that were generated, right? So, Bolt will be able to detect such things uh, by like going through all the file open, file edit events, by going through all the process execution events. So it generates a graph of all the processes, all the file events that has happened, and analyzes to figure out like it runs them, like checks them against the rules that this should not be allowed, this should not be allowed, or this is okay. So that way, and it maps it back to a particular action, like which action was responsible for this, so that like the most difficult part of security that I say is like actually remediating it. So not just knowing what is wrong, but actually remediating it becomes really easy. You know, this action is doing something that it is not intended to. Either you go and patch that or remove that, use a replacement action. The beauty of marketplace, you have multiple actions to do the same. Maybe you have stumbled upon the wrong one, you need to go and use the correct one now. So yeah, so this whole actions piece, if you like, these are the capabilities of Bolt, and this whole GitHub Actions marketplace. This is gaining popularity a lot these days, and this whole space, I'll say, is like kind of getting a lot of attention, the good attention from the security folks that we need to prevent it, the bad attention uh, from the threat actors, the malicious players who are trying to target uh, your build pipelines, because they are the gateway to your cloud. Like if you are able to get it, for example. They are gateway to, in many times they are not just gateway to your cloud, they are gateway to so many other organizations cloud. For example, the SolarWinds, the gateway to one build system, like build system of SolarWinds was gateway to 18,000 other cloud accounts. So that was just crazy. So the impact of these supply chain breaches are like the impact surface is too huge. Like so we also found that this particular Argus project by like the Purse Lab from Purdue University, they are also working on GitHub Actions and other stuff related to supply chain security, which was really interesting. We found it, and we also found like like many other like teams working independently to like solve this overall problem of software supply chain security, both from the component piece as well as the process piece. And the last thing, like there is now a OAS top 10 CI/CD security risk as well, like which is the like kind of, if you want to just understand what is your current state of uh, what are the things that you have taken care of, what are the current things that you don't have, and whether you need a CI/CD security. So this is a great checklist to just look at, just see have you taken care of all these top 10 things. This more or less means, yeah, you are secure. And we have built Bolt and will continue to build Bolt in a way that you don't need to read through this. You just need to put Bolt, make it part of your workflow, and it will take care of all the different threat actors that it has. Uh, so yeah, that is the intention with which we have built Bolt, and we want to continue to build it that way. And with more and more community input, we want to improve it further, take it to the next level, where it takes care of all your, like you don't need to think about like what all bad can happen in your build environment, because
Mhm.
it will be secure by design.
So, I think that's a good segue into what I wanted to ask in terms of what are your plans for Bolt themselves. And I'll phrase this very specifically. So I imagine there's a lot of utility for Bolt, not just for individuals who maintain, let's say, build pipelines and things like that for their own projects, but also in a lot of large enterprises, in a lot of companies that are between this single person and a cat to large
Right.
Fortune 500 companies and things like that. And so are there problems that are very specific to these different personas? And it can be a very broad set of features and a broad set of capabilities, right? So what sort of is your target segment right now, or are you going for a broad based approach in terms of Bolt being an answer across these org sizes?
Great. See, Bolt, like we have built it so that it can be used by anyone, a company of any size. They can just make it part of their workflow and it will start giving them an overview. So you need not to configure everything, but you need to be on top of, like, you need to have access to the data that is like what is going on inside your build environment. So, like, even the smallest of the teams can go and figure out like what is happening inside their CI/CD. Now, coming to your question, like in its most like simplest configuration option where it is running in audit mode, where it is running with simple like without any specific egress rules. One can simply put just one line of code and make it part of their pipeline, and it will start giving you data into like visibility into what is happening. Then for the like as the organization grows and like their security maturity improves. So I'll take a moment to like highlight on the security maturity piece, where like if your organization is growing, it will first secure its cloud, then it will mature further and will go to secure on CI/CD security itself. And this is also a reason why like in the larger organization where cloud is already secured, attackers are targeting CI/CD systems. So that is not much of a problem for smaller, uh, uh, like smaller orgs where because they will not be targeted for it. But it's always good to secure everything that you can. And uh, since securing your build system should not be a hassle, should not be a problem, should not be a continuous maintenance task. With that idea in mind, we have built a secure by design solution that you add Bolt to your CI pipeline, and it will give you a peace of mind security that okay, now like I am secure against all the known threat vectors in CI/CD space, and someone is working so that it remains so. So, yep, that is the idea. Uh, and as the org, like the team size or the org size grows, and let's say if we talk specifically about enterprises, so over there the scale is humongous. Like there are like thousands of repositories, thousands of developers working. So there is a like there is a offering on top of Bolt where we kind of aggregate all the data. We aggregate even the observability part of your pipelines, and we have early warning systems where like if some if you detect something going wrong or some metric moving in a abnormal way, we alert you to like inspect further, or if we have a exact if we can pinpoint the exact root cause, like we provide you with that. Uh, so the offering on top of Bolt that we are building is more targeted towards enterprises, where like which needs to like which have a much larger size of workloads to run, much larger footprint in terms of repositories, developers, or the code base itself, or build pipelines.
Got it, got it. Yeah, that's kind of what I imagined to be true as well. But I think that was a fantastic demo, Abhishek. Thank you so much for you know prepping the demo in a fashion where I didn't have to open my mouth, and everything that I could think of in terms of questions just kept flowing one after the other. I thoroughly enjoyed the entire flow of today's demo, and I'm sure a lot of the people who are watching this will be very tempted to try and apply Bolt to their build environments and other things. And um, based on that, what's the best way to get feedback out to you? Open issues on GitHub, just use GitHub discussions, or is there any way that people can reach out to you directly?
Right. So I will say the best way is to open a issue, and if you feel like contributing, open a PR uh, on our open source project, and yeah, those will be more than welcome. So, like to all our viewers, like the first thing I would request is it's a open source tool. Go give it a try, make it part of your GitHub Action workflows. See, there might be some hiccups, you might face some challenges, but we are here to solve it for you. We will build it together and make sure that everyone has a secure by design CI/CD pipeline for themselves. And yeah, right now the offering is for GitHub specifically, but it is easily extendable. We plan to extend it to other platforms as well in future. So if the need be, if you think you need it for some other platform, again you can come to our GitHub repo and raise a request, raise a issue. We can discuss the details, and yeah, we can maybe with your help we can develop it as well.
Fabulous. Thank you so much, everybody who've been watching this live. For those who are watching this at some later point, I'm glad you could discover the stream. There's a lot more in terms of content, not just between me and Abhishek, but several security experts who are always sharing their thoughts using the OpenSSF channel and things like that. Last thing before I sign off, there's an event this week in Pune. So that's the Saturday, 4th of May. So if you scan this, I'm lost track of how many QRs I've showed today, but if you scan this QR, you can get access to the meetup page that has all of the details to what we are doing this weekend. And if security be a jam and you're in the Pune area, or you can get there by Saturday morning, I would highly recommend joining us for in person to discuss security stuff. So the agenda, the venue, the sign up process, all of that is on the meetup page. So do take a look when you have time. All right, that's a wrap. Thanks so much, Abhishek. Hopefully, we get to see you at some future event or on some future streams. And I wish the Bolt project and Koala Lab the very best in terms of growth, in terms of productivity, and all of those things.
Thank you, Ram, for having like giving me this opportunity to present what we have created to the world. And yeah, with the feedback from the community, we can make it a huge success, I believe, and can make the like the whole CI/CD pipeline piece as much secure as it can be. Yeah.
Absolutely. Thanks, everyone. Bye bye.